Okay, so no need to answer. Alright, so here it says, which diagram shows the correct pattern of the reflected water wave? Alright, so this one you have to measure, you have to see first the wavelength before it being reflected. So the wavelength before it being reflected must be same, okay, after it being reflected. So here you can see there is no change of wavelength here. And another thing you have to know, the law of reflection say I is equals to I. Means angle of incident is equals to the angle of refraction. Okay, so means this one the angle must be same. So the answer should be A. Okay, so for this one the answer is A. So let's check your answer. A, C. Okay, some answer C. Why C? Okay, no need to answer. Okay, so this one the angle is changing. Okay, no, law of refraction said the angle must be same. So this one theta, this one also should be theta. Okay, so mostly got A. Okay, A, D. Shonky, why you choose D?
Sorry, teacher, I saw it wrongly.
Okay, so remember the wavelength should be same, the angle should be same, alright? Okay. You mean also answer D, okay? So remember wavelength same, angle also must be same. So you have to see after and before, the wavelength must be in the same, okay, length. Okay, so the answer is A. Alright. So we move on to another one, the next questions. So which of the following characteristic of wave change when the wave are reflected? So if you listen to what I said, okay, before we start the quiz, okay, so maybe you can answer for this one. Yeah, give 30 seconds more. Okay, so let's say you still didn't submit. Okay. Alright, so let's check the answer. So it says here, which of the following characteristic, okay, which of the following characteristic of wave change when the wave are reflected? Teacher, I log in 2 account. Okay, alright. Okay. So it says here what change? Alright, so the answer should be direction of propagation. Alright, while the speed, wavelength, and frequency, there is no change. Okay, so the answer should be A. So let's check the answer. Right, good. A. Marian, why you answer D? Why D? Okay, very good. I type wrong answer. Okay, so actually you want to answer A, but you type D. Is it? Oh, okay. All right, so next questions. It says here the diagram shows a wavefront of a plane wave incident on a plane reflector. So which statement is correct about the reflected and incident wave? Okay, 27. Lexi, Yvonne. All right, all answer ready. Very good. Okay, so let's check your answer. Okay, so it says here, the diagram shows the wavefront of a plane wave incident on the plane reflector. So which statement is correct about the reflected and incident wave? Okay, so the answer should be, they say A here, the speed of the reflected wave is the same as the speed of the incident wave. Okay, so the answer should be A. Alright, the speed must be same, okay, for the incident wave and also for the reflected wave. Number 3, the answer is A. Okay, so let's check your answer. Picker D. Why you answer D? Okay. Qing Yang also D. Tong Zuan also D. Okay. Later I will check why you answer D. Okay, never mind. Don't answer that one first. I want to check why you answer D. What is the D actually? D, the direction of the reflected wave are always right angle to the incident wave. No, right? Because the law of reflection said, okay, the angle of the incident must be same as angle of reflected. But it doesn't mean it has to be 90 degrees. So if 90 degrees mean 45 for the incident angle, 45 degree also for the reflected angle. Okay, so it's not, right? They say if 30 degrees. Okay, so they say if I have an incident wave, okay, from the normal line, this is 30 degrees, this is also should be 30 degrees. Okay, so it doesn't need like to be 90 degrees, then the reflection occur. No. Okay, it can be any angle. But as long, okay, the angle of the incidence and the angle of the reflected wave must be same. It doesn't need to be 90 degrees. If 90 degrees mean 45 degree here and 45 degree here. So let's say for 30, for 60 degree, if 30, 30, the reflection of wave cannot occur. No. Alright. It still can be reflected. Okay. But the angle of I and R must be same. But not like 90 degrees always. Okay. So please remember that one. It doesn't have to be the right angle. The right angle is actually for the normal line. Okay. For the normal line and also for the normal line and for the surface. The normal line here is 90 degrees. Okay. Yeah. There's a 90 degrees. Alright. Okay, so I hope you are clear about that one, about the angle. Okay. Alright, so let's see about this one, for this one. The reflection can occur at any angle. Okay, but when the reflection occur, the only thing you need to remember, the angle is same. So let's say if the angle of incident is 10 degrees, means the angle of reflected also 10 degrees. It's not 90 degrees always. So it says here, which comparison is correct about the reflected sound wave and the incident sound wave? Okay, so you have to know that reflection is not occur at the water wave only. So it can also occur for the sound wave and also for the light wave. Okay, and light is actually example of the wave, but that one is a electromagnetic wave. Okay, and electromagnetic wave is actually example for the transverse wave. So let's check who still didn't submit the answer. Rachel and Sylvan. Rachel? Are you okay, Rachel? Yes. So, did you submit the answer? Or you cannot submit the answer? Because sometimes we are having a problem, we cannot type the answer. Done. Okay. All right, so let's discuss the answer. Okay, so it says here which comparison is correct about the reflected sound wave and the incident sound wave. So even like sound wave, water wave, or light wave, okay. So actually, all of them have the same characteristic. The speed, all right, the speed, the wavelength, and the frequency will not change. Okay, so the answer should be B boy. Okay, B boy. So let's check your answer. B, 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 B. Okay, very good. Okay. Okay, so next questions. Okay, this one you have to calculate the depth of seabed. Okay, so what's the formula that you should use to find the D, to find the value of D here? What is the formula? That is V is equals to 2S over T, or some we use S is equals to VT over 2. Okay, both also same. Okay, tuition, all right. Okay, okay. All right, so here it said what is the value of D. So if I use the first formula, okay, V is actually the speed. Okay, so the speed is 1,500. Okay, and S is actually the depth of the seabed. Okay, this is actually also equals to S. Okay, and the T is actually the time. So the time is set 2 seconds. So you will receive the echo after 2 seconds. So this should be 3,000, right? Multiply by 2, and again you have to divide by 2, so you will get 1,500 meter. So the answer is C. Okay, so let's check. C. Okay, very good, Shwanki. You show your calculation. Very good. All right. Well, I saw someone answer D. Okay. What formula did you use? Did you use the V is equal to S over T? How can you got D for this one? Did you divide by 2? Right, very good, Junhin. Rachel, okay. Okay, Jayi got B. Alright. So use the formula. Just use this formula. Okay, means this one you have to find the s. S is actually the depth. Okay, the depth, the distance. Okay, all right. So the one that you need to find is s here. Okay, this is the speed and this is the time. Okay, then you just this one go here become multiply and then you divide by 2, or you can just straight away using this one also can. Okay, all right. This one also use the same formula. Okay, for this one you need to find the distance of the aeroplane from the radar. It says a radar transmit a signal towards an aeroplane. Okay, and the velocity of the signal is 3 times 10 power of 8. Okay, after 4 times 10 power of negative 3 seconds, the radar detects the reflected signal. What is the distance of the aeroplane from the radar? So again, you can use this formula. Okay, or you can use this one also can. Yes, Li Jiying. You have any questions?
Teacher, just now I typed wrong my answer.
Oh, you typed wrong answer.
Ah,
You already submit, is it?
yes.
Okay. Actually, what is your answer?
C.
C. Okay, I noted. Because once you submit, you cannot make a correction. Okay. Okay. So close insert result. Okay, so let's check your answer for this one. Okay, so let's say I use the second one. All right, so S is equals to Vt over 2. So here the velocity is 3 times 10 power of 8. The time here is 4 times 10 power of negative 3. And also you divide by 2 after that. So 3 exponent 8 multiplied by 4 exponent negative 3. And then you divide by t, you get 600,000. So the answer should be C. Okay, so let's check your answer. Okay. Erin, you got B. Fizian, this one you already give me. Yes, so it's C. Careless mistake. All right. Okay. Very good. Some of you show. Yang, you got D. How come you got D?
Teacher, I put as the V I put actually is S. This is the 3 times 10 power 8 put as S.
Okay. So please be careful next time. Okay. All right. Very good. Okay. This one. Which of the following graph shows the correct relationship between the wavelength and the frequency? Okay, for this one, I give you a clue. You have to refer the formula. That is V is equals to F lambda. Okay, and then you have to arrange the formula. Okay, so then you can find what's the relationship between the lambda and the frequency. Okay, I give 15 seconds. Because this one no need to calculate anything. Just see the graph and choose, right? Okay, done, close. All right. So let's check the answer here. Okay, so V is actually equals to F lambda, right? So if I arrange back the formula, okay, so I got lambda is actually equals to V over F. Okay, so from here I can see if my frequency is lower, okay, my lambda will be increased or my wavelength will be increased. Okay, so this is actually shows the relationship of the graph. That means this is inversely proportional. So the answer should be C. Okay, but if the x-axis is 1 over f, okay, so they say this is the lambda and this is 1 over f, so the graph should be directly proportional. Right, so the answer for this one, question number 8, is C. Okay, very good. All right, some of you said A, D, right? D, B, A. Okay, so most of you got C. So can you understand why I said the graph is inversely proportional? You arrange back the formula and you see the relationship between the lambda and also the F. So here when the F is decreased, the lambda will be increased. So means this one is the inversely proportional. Alright, so when the graph inversely proportional should be curve, okay, curve downward like that, but it will not touch the x-axis. Okay, but if you put the directly proportional, let's say if you choose A, I think A is this one. This one directly proportional means when the frequency increase, okay, the lambda also will be increased. Okay, but no, it's not happen like that. It's just like when the frequency decrease, lambda increase. Okay, so you arrange back the formula. Okay, so I think, yeah, think this will be the last because after this you need to present. So what happened? Okay, and this one, there's no answer. Okay, don't choose A, B, C, D. Okay, you write your own answer, wavelength and also the velocity. Okay. Wait. Magnitude or velocity? Yes. You got the answer here. You can choose A, B, C, or D. I thought you put the velocity. If you put the magnitude, can. If they put velocity, then it's wrong. Velocity will change. You can choose A, B, C, D. Okay, so let's check who still didn't answer. Oh, Ji Yin. So now you have two names, is it? Oh, okay, so I will close. All right, so here it says what happened to the wavelength and the magnitude, okay? Magnitude of the velocity, okay? Magnitude of the velocity, okay? Not the velocity, but the magnitude means the number, okay? So here means both unchanged, okay? So number 9, the answer is A. No answer. Not answer, Yelim, because it said magnitude of velocity. If they said velocity, then no answer. Who answered B? No, Viresh, the answer is A. Okay, because we already know the reflection all is not changing except the direction of propagation. Okay, C, D. Okay, but mostly most of you answer A. But still some of you answer B and D. Okay, so I hope you are clear. The wavelength is not changing. The magnitude, the magnitude of velocity means the speed, right? Because if the velocity, they have to consider the magnitude and the direction. But since it's only mentioned about the magnitude, okay, mean it mentioned about the value only. Doesn't matter about the direction. Okay. So the answer should be okay. All right. So is there any question for this? No. Okay. So are you ready for your presentation? Shwanki, of course you're ready because you're already done. Okay. So let's see. So evil. All right. So this is 4K just now. Okay, so make sure you're ready with your PowerPoint. Okay, your mic is working. Your video, you can play your video. Okay. So let's see who's the lucky one for today. All right, Marian. Marian, are you ready? With your PowerPoint and also with your mic. Marian, okay. Okay, so I will give it to you, my screen. Stop share. Okay, go on, good luck, all the best. Don't be nervous.
Okay, a very good afternoon to Panyus Balina and my friends. My name is Marian and today I'll present about my physics project, which is vacuum cleaner. The physics principle that I use is Bernoulli's principle. So the materials that I use are used aluminium can, empty container, lace net, aluminium foil, plastic strip, empty plastic bottle, wire, motor, switch, and batteries. So this is my process of making the vacuum cleaner. Okay, so next, how is my physics principle is used? So the vacuum cleaners work because of Bernoulli's principle, which states that as the speed of air increases, the pressure decreases. So air will always flow from a high pressure area to a low pressure area to try to balance out the pressure. So a vacuum cleaner has an intake port where air enters and an exhaust port where air exits. The fan inside the vacuum forces air toward the exhaust port at a high speed, which lowers the pressure of the air inside, according to Bernoulli's principle. This creates a suction. The higher pressure air from outside the vacuum cleaner rushes in through the intake port to replace the lower pressure air. The incoming air carries with it dirt and dust. So this is how the vacuum cleaner sucks dirt and dust. So this dirt is trapped in the vacuum cleaner, but the air passes right through and out of the exhaust. So this is my modifications done to the object. The modifications that can be done to the object is enlarge the opening of the plastic container. This is to make the opening of the vacuum cleaner bigger to suck up more dirt. Besides, we can also add a handle on top of the vacuum cleaner so that the user can use the vacuum cleaner easily with a better grip. Next, we can also put a filter bag in the vacuum cleaner. This is to trap and store the dirt and dust particles that are sucked into the vacuum cleaner. So this is the end result of my vacuum cleaner.
Marian, can you please play again the video for me? Okay, thank you.
And lastly, these are my references. And that's all from me. Thank you.
Okay, very good project. All right. Okay, so you did a vacuum cleaner. Okay, so very interesting. Okay, so we move on to the next one. Okay, wait, I share my screen first. You don't know who's the lucky one, right? Okay. Okay, surprise. Okay, so it's Chua Kenye. Are you here?
Yes, teacher.
All right. Okay. So are you ready?
Yes. Wait
All
a
right.
while.
Okay.
Teacher can see the screen.
Yes, I can see the screen.
A very good afternoon to Yusfalina and to all my friends. So my project main topic is about Newton's third law, and the product that I'll be making is mentor skateboard. And here is my table of content for the whole PowerPoint. So first of all, I will be introducing to you all my material and apparatus used. Then secondly, I will tell you all about my procedure. And third, about my modification. And of course, the end of the result. And fourth is to explain how Newton's third law are being used in this product. And fifth is my reference. So first of all is introducing the material and apparatus. The material I use is polystyrene bottle and 4 bottles cap and some sticks. And the apparatus I use is a hammer, screw, tape, scissor, pen, and ruler. Followed by is the procedure. So the first step is a preparation work. We need to use the hammer and screw to make hole out of the 4 bottle cap for the tires. And here's step 2, also preparation work. We need to use the pen and ruler to measure the polystyrene used for the skateboard. Then here are the step 3. So we need to cut the label. I need to cut the label polystyrene out. So in here I cut 2 pieces out because my polystyrene is too thin. So if I have a more thick polystyrene, I will need to do extra work. And then here's step 4, use the tape to tie up both pieces of polystyrene together, like this. And then followed by is step 5, we need to put the stick into the bottle hole and make sure it's not loose, like this. And here's step 6, we need to put the stick together and tape it with a tape. And need to make sure that the both stick that is taped together must be fixed. If you have a long stick, you also can skip this process, like this. And followed by step 7, you can make a hole using a tape and put it here, then put in the tires. And you need to make sure to leave some gap among the hole to make it roll. And then here's step 8, put up double side tape at the middle of the skateboard and stick the bottle on it, like this. And then here's step 9. You need to use the tape to secure the bottle from it, and tada, this is the finished product. And then we'll first test can the skateboard roll. So yes, it can roll. And then now we'll need to test it out for the result. So before we start the whole test, we have to prepare Coke and also some Mentos. Then here's my first try. So throughout the first try, I put the Mentos in a paper to prevent it from bursting immediately. And I just put half bottle of Coke to try the experiment in case it has too much spill. So it results in is that too less Coke to react with the Mentos, and the Mentos that is covered with paper cause it to not react very quickly with the Coke, and did not create any explosion to push the skateboard. So I did some modification throughout it, and then here's my second try. So second try, I add in full bottle of Coke and put in more Mentos without covering, and then I also shake it before I let it go. And then the result is it's success in moving forward, and then here's the burst. And it did not make it very further because due to the friction with the floor.
And then here are my modification. So first of all is the floor surface. I should choose a small smooth floor surface to begin the experiment in order to reduce frictional force. And then secondly is the skateboard material. I should choose a harder material to reduce the weight carried on the skateboard from the cork. And then third is the bottle hole. The bottle hole can be cut bigger to create a larger explosion and make the skateboard move forward. And then fourth is the gas in the drink. I should use the original bottle of the Coke for experiment to save more gases in it and create a better explosion. And then now I'll explain about Newton's third law that I use in this project. So first one is Newton's third law. Newton's third law is whenever one object exerts a force on a second object, the second object also exerts a force on the first object, equal in magnitude and opposite in the direction. And then here is the diagram of skateboard. So the first action occur is the man pushes against the ground with his floor. And then second reaction occurs, which is the ground pushes back on, and this force causes him to move forward. And the reaction is always equal in strength to the action, but in opposite direction. And then here's the product explained. So first, the coke will burst out due to reaction with Mentos, causing it to exert force to the whole skateboard model. And then this helps push the skateboard model move with an opposite direction of the force exerted. And then here's an extra info, which is as Mentos sinks into the bottle, it will cause the product to have more carbon dioxide bubbles. And these rising bubbles react with carbon dioxide will dissolve in the soda to cause more carbon dioxide to be freed and create even more bubbles, which resulting in eruption, which is just now the explosion. And then here are the reference I use, which is textbook, online web page, YouTube, and reference book. And that's all, the end, and thank you for seeing.
Okay, very good presentation. But I'm hoping like maybe because the video does not see the clearly the movement of the bottle, right? I mean, but maybe why not adding more Mentos to it? Is it same? Did you try to add like using more
Yeah, I try
Mentos?
to add more Mentos, but then the gases, because I pour the Coke pouring into another bottle and then another bottle pour into another bottle, so a lot of the
Oh.
gases is lost in the bottle, so it did not make a very big explosion.
Why not like you means okay, never mind. Okay. So let's see another one. We still have time, I think, for one more person to present. Wong Tong Zuen. Wong Tong Zuen. Are you here?
Yes.
Okay. So
Mm,
can you present?
can you see my screen?
Yeah, I can see a screen. Glider.
Okay, then I'll start. Good afternoon to teachers and friends. Today I will be presenting my physics project, which is glider. And teacher is Puan Yusvalina. The content inside this slide is the physics concept that I use and material used, steps to make glider, video of making a glider, modification, demonstration, and the result, and the reference. So firstly, I will say about the physics concept, which is force. So a glider is a special kind of aircraft that has no engine. A glider has only three main forces acting on it, which are lift, drag, and weight. As before, we have collected all the component forces together and represent them by single forces acting through the center of gravity or the center of pressure. Because of gliders carry no fuels or engine, they are usually lighter and simpler than power aircraft like airplane. In order for a glider to fly, it must generate lift to oppose its weight, and then it can fly. So these are the three forces on a glider, which is lift, weight, and drag. This is the material that I use to make my glider. It's color paper, scissors, and ruler. It's very simple. And this is the steps and video of making my glider. The paper disc that I cut it off is to make it fuselage. And this is the body of the glider. This is the wing. Then insert the fuselage into it. And this is the final, the glider. So now I'll talk about the modification of this glider. First, we can put a paper clip on the glider on the forward part of glider, because this rig of paper clip will help the glider to fly further. Secondly is hold the fuselage when throwing the glider, so it can stabilize the paper glider when it flies. Third is fold a little bit of the wing side, so it can decrease the air resistance acting on the paper glider. And now I will show the results and how the paper glider will fly. And it fly, the height and direction will change, and it will drop. Then now I will explain about the glider. So to generate a lift, the glider must move through the air, but the motion of the glider through the air will generate drag. So in a power aircraft, the thrust from the engine opposes drag, but glider didn't have engine to generate thrust. So with the drag unopposed, the glider will quickly slow down until it can no longer generate enough lift to oppose the weight. And this is the reference. This is the YouTube video that I refer to make the paper glider, and this is the website link. Thank you.
Okay, thank you. Right. So I think we didn't have time for the next presenter, so we continue after the school holiday. Right. So for the school day, all right. Before I forgot, there is no extra class on this Saturday, on the next Saturday. So I give a chance for you, okay, to rest for 1 week, and after that we will continue, right? But I'm not sure whether we have go to school or we have to continue for PDPR. Okay. So anyway, thank you for all the presenters today. Very good. Okay. I'm very impressed with the vacuum cleaner. Okay. Very good effort. All right, so I will see you after holidays. So take care, class. Okay, happy holidays. All right, take care, everyone. Stay safe. Okay, so see you after holiday. All right, and bye.